Today, we're going on a quest, not through some ancient ruins or a dense jungle, but into a place that's way more mysterious and a lot closer to home, your own mind. We're going to try and map one of its most critical and busiest territories, something called working memory.
So, let me ask you a question. When someone tells you a phone number and you have to hold it in your head just long enough to type it out, where is that information? What's that little mental scratch pad you're using? Well, that right there, that's your working memory.
You can think of it like the RAM in your computer, or maybe a better way is to think of it as a mental countertop. It's not for long-term storage, like your childhood memories. It's the active, temporary workspace you're using right this second to juggle all the information you need to get things done, whether you're solving a problem, reading a sentence, or learning something new.
So, how in the world do you even start to study something you can't see? Well, the scientists who first tackled this saw their job as being like old-school cartographers. They weren't looking for a single rule. They were trying to draw a map of the mind. And just like this quote says, a good theory, a good map, doesn't just tell you what's there, it encourages you to go out and explore even more. And that's exactly what we're going to do. We're going to follow the map.
Okay, so our journey starts with the very first draft of this map, which was sketched out all the way back in 1974. It's called the multi-component model, and the big idea was that working memory isn't just one thing. Nope, it's a whole system with 3 different parts, all working together.
So, at the very top, you've got the boss. It's called the central executive. And really, that's the perfect name for it. Its job is to manage everything, to decide what you pay attention to and what you ignore. You know when you're driving and having a conversation at the same time? Your central executive is the one juggling both of those things, shifting your focus between the road and your friend. It doesn't really store any info itself, it just directs traffic.
And working for the boss are 2 really specialized assistants. On one side, you've got the phonological loop. This is basically your inner voice and your inner ear. It's what you use to keep repeating that phone number over and over in your head so you don't forget it. And then, on the other side, there's the visual spatial sketchpad. That's your inner eye. It's the part of your mind that lets you picture your living room and mentally figure out if that new sofa is actually going to fit. So a map is just a piece of paper unless it actually matches the real world, right? So how did scientists figure out if this 3-part system was for real? Well, they acted like detectives. They ran some really clever experiments to find clues that would reveal how these hidden parts of the mind actually work.
All right, so the first big clue they found is something called the phonological similarity effect. Check this out. It's way, way harder to remember a list of words that sound alike, like man, cap, can, map, than it is to remember a list of words that sound different, like pit, day, cow, pen. And the key thing here is that the confusion is all about the sound of the words, not their meaning. That was a huge piece of evidence suggesting we stored this stuff using some kind of sound-based code.
And here's the second clue, the word length effect. Turns out you can remember more short words than you can long words. Think about it. It's easier to remember a list like cat, dog, sun, fish than university, refrigerator, hippopotamus, electricity. And why is that? Well, it's because your inner voice has to actually say the words to rehearse them, and it just takes longer to get through the long ones, giving them more time to fade away.
Okay, now this is the really cool part, where all the clues lock into place. They came up with this technique called articulatory suppression. All you have to do is get someone to repeat a simple word over and over again, like the, while they're trying to remember a list of words. And what that does is it basically ties up their inner voice. And you know what happens? Both of those effects we just talked about, the similarity effect and the word length effect, they completely disappear. That was the smoking gun. It pretty much proved that this inner speech system, the phonological loop, was real.
And the evidence wasn't just coming from these clever lab tricks. It also came from the real world. Neuropsychology was absolutely vital here. Researchers started finding patients who, because of very specific brain injuries, had a broken phonological loop, but their visuospatial sketchpad was totally fine. And they found other patients with the exact opposite problem. This was powerful proof that these 2 systems really were separate.
So, for about 25 years, this 3-part model was a huge success. It explained so much. But the more people used the map, the more they noticed a giant hole in it. A big problem. How does working memory combine information from different sources? How do you link the visual of a friend's face with the sound of their name? The original map had no answer. Something really fundamental was missing.
And so, in the year 2000, the map makers went back to work. They didn't throw out the old map, not at all. They updated it. They added a new piece to the puzzle that would solve this massive problem.
You can see the evolution so clearly here. The original 74 model shows the boss, the central executive, with its 2 assistants. But look at the updated model. They've added a 4th component, called the episodic buffer. And you can see how it acts as a bridge, connecting the verbal and the visual systems to each other. And, this is critical, connecting them both to our huge library of long-term memories.
So what exactly is this episodic buffer? Well, you can think of it like a mental movie screen. It's a temporary space where information from your inner voice, your inner eye, and your long-term knowledge all get projected together. It binds all those different pieces of information into one single, coherent episode. It's basically the glue that creates the rich, unified conscious experience that we're all living in moment to moment.
All right, so that update was over 2 decades ago. Is this map still useful? Does it still matter today? And the answer is a huge, resounding yes. The legacy of this map is just enormous.
The real power of this model is how it gives us one single framework to understand a crazy range of findings. It connects simple lab results to complex, real-world things like how we learn languages. It pulls together evidence from our behavior, from patient studies, and even from modern brain scans. And maybe most importantly, it's just a fantastic example of how science should work, a theory that wasn't set in stone, but that grew and evolved as new discoveries were made.
Now, let's be clear, this isn't the only map of working memory out there. Science is always full of competing ideas, and there are definitely other important theories. But the basic structure of this multi-component model has been so useful, and it's guided so much research for so many decades, that it's a true landmark in our quest to understand how our minds work.
So we followed these cartographers of the mind as they drew and tested and redrew their map of working memory. It's an amazing story, but it leaves us with one last, really exciting question. If this is the part of our mind that we've managed to map so far, what other uncharted territories, what undiscovered continents are still waiting in there to be explored?